In this problem again we are doing another example of graphing a rational function. So the first foremost is I have to factor the numerator and denominator completely. So if I factor the numerator, I'll have y equals, I can take out an x, so it'll be a 2x minus 3, and the denominator is already in a factored form, so 2x plus 5. So there is nothing common in the numerator and denominator to simplify. Therefore, I will have to keep proceeding to the next step, finding the vertical asymptote and the x-intercept. Again, this is of the form p over q. The p in the numerator equal to 0 gives me my x-intercept. Q equal to 0 will give me my vertical asymptote. So first, to find the x-intercept, I would take x times 2x minus 3 is 0. Therefore, x equals 0, 2x minus 3 would be 0. X would be 3 over 2. So these are the two x-intercepts, 0, 0, and 3 over 2, 0. Okay, those values I will input here. Okay, it's telling me smaller value first. Okay, so the next one I need is the y-intercept. So let me finish my y-intercept before going to the vertical asymptote. So for y-intercept, I need to plug in x equals 0 in the function. Therefore, y is equal to 0 times 2 times 0 minus 3 divided by 2 times 0 plus 5. So it's a 0 over 5, which is 0. Therefore, y-intercept is 0, 0. Okay, so the next step is to find the vertical asymptote. Again, to find the vertical asymptote, I'm going to take my denominator and set it equal to 0. So 2x plus 5 equal to 0. Therefore, x is equal to negative 5 over 2. Again, the vertical asymptote should be written as an equation, x equals negative 5 over 2. Okay, now since the numerator, okay, so I need to look for the local maximum, local minimum. I'll come to that in a minute after graphing the functions. But looking at the horizontal asymptote and oblique asymptote, and we know the condition is for you to have a horizontal asymptote, the numerator degree has to be less than the denominator degree, or the numerator degree should be equal to the denominator degree. If the numerator degree is greater than the denominator degree, then there is no horizontal asymptote. So if I go back to this problem, let me write the question down here so we can see this. Y is equal to 2x squared minus 3x divided by 2x plus 5. Again, I'll write it in the factored form. 2x plus 5. So if you look at the numerator degree of the numerator, which is 2, degree of the denominator 1. So since my numerator degree is greater than the denominator degree, there is no horizontal asymptote. But since my numerator degree is 1 more than the denominator degree, in this case I have an oblique asymptote. Okay, and to find the oblique asymptote, I need to do long division. Okay, so let me do that first. So I'm going to take 2x squared minus 3x plus 0, put a placeholder for any missing terms, 2x plus 5. I'm going to do long division. The first step is to look at this first term and look at the first term here, and to find what the quotient has to be, like I'm going to take 2x squared over 2x divided on the side. Now no x and x cancels, so I'll end up with an x, right? So this x has to go up here, and that is the x. I'm going to multiply this entire 2x plus 5 term. So this x I'm going to take and I'm going to multiply it over here for this entire thing. So that is going to give me 2x squared plus 5x. Just write it below this. And now you need to subtract entire quantity there. So this 2x squared cancels. Negative 3x minus 5x is negative 8x. And then bring down the 0. Now repeat the same process. The negative 8x and the 2x, right? So what needs to be multiplied to find that? I'm taking the negative 8x on this side, divide by positive 2x, getting a negative 4. Alright, so that goes up here. And now this negative 4 needs to be multiplied throughout for this function. So it's negative 4 times 2x plus 5. This would be negative 8x minus 20. Now, I don't have to worry about the denominator. I'm getting a remainder of 20. I don't have to worry about that. What I need is this part here. So this is giving me my oblique asymptote, y equals x minus 4. So this is my oblique asymptote. Okay, so if I go back to the top of the question, it says use long division to find the polynomial that has the same behavior as the rational function. It's asking for the oblique asymptote here. So why put g of x, they already did for me. I would write x minus 4 here. It's a linear function. Okay, now the last part is to look at the graph of the function. So we can, before going to the calculator, we can just look for what the graphical representation would be. When I know that the vertical asymptote at x equals negative 5 over 2. So since this has a positive asymptote, so it's showing a positive side, right? So that cannot be the graph. Here also I'm seeing a positive asymptote, so that cannot be the graph. Here I have a negative, so either one of this should be the function. So the x and the y-intercepts is 0, 0, so that's not going to help me. There's another x-intercept of 3 over 2 comma 0. X is 3 over 2 comma 0. So that's also not going to help me because it looks like I cannot clearly see it. So here I don't know if it's crossing or touching there. But anyway, still that's not very clear. Oblique asymptote is x equals x minus 4. So oblique asymptote is an equation of a line which is of the form y equals mx plus b, right? So I'm seeing this y equals x minus 4, which is y equals mx plus b. So the slope here is 1. So slope is 1, which is a positive slope. So that's telling me that if I look at the blue graph here on the left, this blue line is giving me a negative slope. Therefore, this cannot be the graph. And I think this should be the graph. We'll confirm it by graphing in a minute. This must be the graph of this function. Now, when they say look for the maximum and minimum, they want to know what this point would be. This would be the max, local max, and this would be the min. And you need to use your calculator to find those values anyway. Okay, but at least we know where we are looking for, okay? So another thing is when you graph this, like make sure your x minimum, x maximum matches with what you see here to avoid sitting and changing the windows, because it's already there, right? The graph is there, so why don't I use that reference to graph it? Okay, so let me go graph the function. I'm going to input it y equals. Again, I can do it the factored form or the unfactored form, it doesn't matter. You can, because nothing is getting cancelled, so I can write it either way. So 2x squared minus 3x, I'm putting the original question in, divided by parentheses 2x plus 5. Since I already know my viewing window, I'm going to stick with this. I'm going to take my x minimum, negative 15, x maximum 15, and I'm going to keep the scale the 1, it doesn't matter. Y minimum, I'm going to go negative 40, and y maximum, I'm going to keep it 40. Hit graph. And you see the graph, and it matches with what I'm seeing here. So I need to look for this maximum point, because the question is asking us to find the local max minimum, right? It's asking local maximum, local minimum. So to find this maximum point, I'm going to go second calc, maximum. If you keep on going, it will come. Okay, so coming to a little bit to the left, enter, enter again, so somewhere there is the maximum. So 5.6, negative 5.66, does it say round it off to 2 decimal places? Yeah, correct your, so here this also is something to remember. It says, and local extrema, correct to the nearest tenth. So I can say this is negative 5.7 comma negative 12.8. The x value is negative 5.7 and the y value is negative 12.8. Okay, same thing, look for the minimum. So second calc again, trace, go to minimum, enter, okay, use the right arrow, and it will jump to the other graph, piece of the graph. Okay, bring it down a little bit closer, okay, enter, okay, enter again, enter, it's giving me the minimum value, and it is 0.10, right? So 0.7 comma negative 0.2. 0.7 comma negative 0.2. Okay, so that's all the problem is asking me to do, and I just analyzed the graph of the function, and I also looked at the shape of the graph and identified and confirmed that all the math I did here is correct.